So, data structures and algorithm lab, experiment number 3. In this lab, we are actually asked to implement a single linked list with all the basic functions like insert at front, insert in any given position, insert at back, then delete at front, delete at any given position, and then delete at back. Okay. So this is my code. After I show you the example, then I'll go through the code. So first I'll just show you how my code works. So here, so first, okay. So as you can see, I can do any of these operations. I'll first insert a front. So insert a front, say 100. Then I'll insert at front again, say 200, and again I'll insert front, say 300. And now let's display this uh, like like now let's display whatever is there in the single linked list. So as you can see, it's these are the elements. First we inserted 100 in the front, then we inserted 200 in the front, then we inserted 300 in the front. Okay. So now like so now so now so now uh, so now I'm gonna insert at the position 1. So here is 0 and this is 1. In the place of 200, this newly inserted node should come. So let's see. I'm gonna insert 400. So at position 1, it's asking the position, I'm giving it 1. So now let's just play 7 for display. So as you can see, I've inserted 400 at position 1. Okay. Now let me insert at a position which is not there in the linked list. Say for example, uh, let me insert at 8. As you can see, there are only 4 elements. 8 is not here. So let's give 8. Okay. Okay. By mistake, I gave the data as 8. Okay, still, it doesn't matter. I give 8. So as you can see, this program gives an exception here. As the given position exceeds the number of positions given in the linked list, this element will be added to the end of the list. So now let's verify if it's there in the end of the list. As you can see, it's automatically added to the end of the list. So that's also working. So that edge case is also working. So what if I want to insert at the last position of the list? I can give insert at back, say 3. What element shall I insert? Say 500. Now let's display. As you can see, 500 is displayed at the end of the single linked list. Okay. Now let's perform a delete option. We want to delete from the beginning. So let's give 4. And now let's display the elements. As you can see here, 300 was in the front. As soon as I gave delete, it automatically got it deleted. Now 400 is there. Now let's delete from any position. Say uh, the first position, that is we will delete the element 200 which is in the first position. So 5, position number 1. Okay. Now let's explain. As you can see, 200 got deleted. So that also works. Okay. What if the users give, like, what if the user gives some position which is above the size of the linked list? Here there are only 4. Like, what if the user gives 8? Let's see what happens in that case. So 5, position number 8. Okay, there is there is an exception message being printed. As the given position exceeds the number of positions given in the linked list, the last element in the linked list will be removed. So that edge case is also taken care of. So, and like, what if we want to? Okay, as you can see, the last element 500 was removed from this. So, what if we want to remove the last element in the linked list? Okay, that is 8 in this case. So let's give 6 for that. Now let's display. As you can see, 6 got deleted. So this program works for all the given cases and for additional edge cases. So now let's go through the code. So first thing, uh, each linked list as a node. I implemented this node using a class. So class, in this class I have a data variable to store the data and a node pointer called next to store the address of the next node. Okay, so and I'm using a constructor node which has an argument to give in a data. Okay, and that data is being stored in this data variable of this node, and automatically next is initialized to null as default. So first thing, before I explain all the functions, I'll just explain the main function. This is a code that I will be using to print this signature. If you see, if you notice this thing, so that isn't part of the program. That is just for identifying that code is for me. Okay, just a minute. Okay. So initially, I'm having a temp variable for inputting values from like in different stages. Then I'm initializing a head pointer of the type node, the class to null. Okay, and then I'm having two variables choice, so the choice, and position for certain cases. Say insert at any position will also have a position input. So for that I'm declaring it here as well. First I'm inputting choice, then while choice not equal to 8. As you can see, 8 is exit here. If it's not equal to 8, the while loop will be running. So I'm using a switch case here statement here. If it's case 1, then insert at head. So as you can see, case 1 is insert at front or insert at head. So case 2 is insert at any position. So here I'm asking the user to enter the data to answer that is stored in temp. Same thing here, but with an additional input called position, and it is passed to this function. Here it is insert at end, asking data and pass to this function. And all these three are for deleting. First one is deleting the head. Second one is deleting at a position. So for that I'm getting a position from the user. Last one would be deleting at the end. Okay. Then 7 is for printing the entire single linked list elements in the single list. Then, if the user gives any other character, say B or 10 or some other number, you just say wrong choice and try again. That's it. So after that, uh, after this is getting executed, I'm just printing this thing and getting the user's choice. So if the choice is equal to 8, this loop will break out because 8 is exit. Until it becomes 8, this thing will be executing again and again. The first function, insert at head. Okay. If you notice here, I'm using pass by reference. I'm accessing the head's actual value. Here in the main function, there's this head, right? I'm accessing its actual value. So it's passed by reference. So here, and I'm just getting the data. So if the head is equal to null, that means there's no linked list being created. In that case, we give head is equal to new node of data. This new dynamically makes like an object of node. Uh, if you can see, there's this construct. Okay, sorry, this thing. If you can see, this constructor automatically assigns this. This makes an object of this type node, and it stores the address in head, and then it returns it. If head is not equal to null, then these statements will be printed. These statements will be executed. Here, if you can see, I'm using a pointer of type node, and I'm just making a new object of node, and I'm just initializing it with the given data. Now, I'm just as its head, the logic is uh, this new node should point to the current head's address. So n of next will be the current head's address, and head's address should be the new node's address. So it is equal to n. That's it. This is inserted head. Inserted head. Okay, here also like if head is null, then the same thing happens here. This same thing is happening. So if it's not equal to null, then we have a point. We have iterator as well. Okay, it's actually a pointer variable of type node head, which I'm using as an iterator. So while temp of next not equal to null, the this loop executes. Temp will become temp of next. So the objective here is to go to the last node and add a new node there. Okay. This loop will execute. This loop will uh, will run until temp points to the last node, because only the last node will have its next is equal to null. So until that will run. Then if you see here, here we are making a new object and of type node, and we are initializing with the data to call in the constructor, and we are assigning it to a node pointer n. And now temp of next will be equal to n. So this temp will have the value of the last node, right? So just a minute. Okay. So so this temp will have a value of the last node. Okay. So yeah. So so last of next should be equal to the new node. That's done. So delete head. Okay. So delete head. So if you see this, okay, insert at end is over. Then I'll go to delete head, deleting the node at the head position. If head is equal to none, then there's this message being printed, no elements indexed. I didn't show that example there. Uh, if it's not equal to null, then this will be printed. Node star of temp will be equal to head of next. That is, just a minute. So say like if this is first one, this is the first node, and this is the second node. Okay, so head will be pointing to this, right? So head will be pointing to this. So now what we're doing here is node star temp is equal head of next. We are having a pointer which is actually storing the address of this one. So head of next will be the address of this. So this will be stored in temp. Okay, and now what we do is we delete head. That is this. That is this node is deallocated, destroyed. Okay, and we head pointer is not destroyed, but this node is destroyed. Okay, and after that what we do is we assign the after that what we do is we assign the value of head. Just a minute, uh, assign the value of head to point to this node. This is the logic. That's it. uh, this is delete node. Now delete at end. What this does is if head is equal to null, stack overflow, there's no nodes in the there's no nodes in the there are no nodes in the ceiling list. If head of next is equal to null, then delete it. That is, if there's only one element, then we just delete the head and then give head is equal to null. Oh, like if the head is pointing to the last element. That is, if the single linked list has only one element, that element next will obviously be null. So if that is true, then we just delete uh, that node and have head point to null. Then we return. But uh, if there are more than one nodes, what happens is we have this pointer which will go until the let me draw this into. Let's say there is one node, two node, three node. Say we want to delete the last element. Okay. So what happens? So what happens is, so until this head, so initially ITR will be equal to head. Head will point here. So ITR will also point here. So ITR next of next. ITR's next is this. Its next is 3. If it is not equal to null, we make ITR is equal to ITR next. So ITR will become this. So now ITR next of next, is it null? Yeah, it's true. So what happens is we have this loop breaks. We have this temporary variable storing the address of ITR. ITR is shifted to the next variable. Then ITR is deleted. Okay. If you see this temporary variable, we have the address of ITR. That is temp will be pointing here. So now we need to make the temp of next is equal to null. So after deleting, this will go, this will go. Okay, ITR was deleted. Now it assign this is export as null. That's it. This is the logic. Now let's go to the next one. Insert at any position. Here we have. Okay, if you note here, all of this I'm using pass by reference for all these functions. I insert at any position. Here, if head is equal to null, that means there are no elements in string linked. So directly we can make a new one. Okay. Why I gave this is sometimes the single linked list can be null, and say the position is 2. There are no elements in the single linked list. At that time, this message will be printed, and this node will be added into front position ahead this. So okay, this is if position is equal to 0, that is first position. Then I'm just calling it insert at head. Both are the same. Position is 0 means inserting at the head. I'm just calling it insert head. And now I'm having iterator head, and I have count is equal to 0. I'm iterating until count is equal to position minus 1. Until it is equal to position minus 1, this loop will be going. But if it breaks before, like if ITL becomes null before that, that means there are no elements in the linked list. Say 1, 2. Okay. Say if position is equal to 10. Okay. Initially count will be equal to 0. Okay. Then here this is true. 0 less not equal to 10 minus 1 9. So count plus plus will become 1. ITR is equal to ITR next. ITR will go here. See, from here ITR will go to here. Okay. Then here 1 is not equal to 9. True. Then this is false. Count will become 2. ITR will become ITR next. ITR next will be null. So the current value of ITR uh, will be null. So what happens is, so the position is 10, but there are no such elements in the list. So this message is printed, and it's automatically inserted at the end. But say the position is 1. Okay, so initially it will be 0 not equal to 0. So this entire statement won't run. So this entire statement won't 0 not equal to 0. So this entire statement won't run. Okay. So we need to insert it here. The logic behind this is very simple. Let me explain. So here we are going to make a brand new node called temp. Then we are going to make temp of next point to this. Okay. And then we are going to make iterator of next. Okay. Okay. And then we are going to make iterator of next point to 10. This point to 10, and automatically this will be erased. That's it. This is the logic. So that's them. Let's go to the next one. Delete at any position. This is almost same as this, but here only thing is will be dating the elements. This is also the same, but here it's like iterator of next of next. The logic. I'll just explain the logic behind this. So here, okay, sorry for the bad drawings. Okay, so this will go until current position is less than 1 and itr of next and next is not equal to null. If this is true, say like the position is 2, that means when I come here itr of next will be null. Okay, so if this is true, that means the element we are going to delete will be the last element, right? Or if the position is greater than the last element, that time also will be like the last element will be deleted. That's it. So that's something. So until this run, say if you want to delete one, so I tell next is not equal to null. So 0 is less. Okay. Uh, the statement don't run as 0 not equal to 0. Then here what happens is if next is deleted. Okay. Say we want to delete. Okay. Uh, this statement will delete if the element is the last element. If the position is the last element, this will be uh, this will execute when the boundary limit is higher than this last element. That's it. So the logic behind this is go here, okay, have a temp variable which stores the address of this IT of next. Temp to store address of this. Okay. Temp ITR will store address of this. That is, I make ITR to go to the variable before last. Then have temp the address of ITR of next. Then what you do is delete temp, okay, and make ITR of next is equal to null. That's what happens here. Okay, ITR of next is equal to temp of next. That is literally making it null. Okay. Sorry, I just made a mistake here. Deleting the last element will automatically be taken by these two delete again. So our objective is to delete this element, right? So the loop content will stop here also. So iterator will be here, temp will be here. So what we're gonna do is make iterator point to this. That is literally break this and make it point to this. Okay. Then what we'll do is delete this. That's all. This is the logic behind this. So that's the last thing. Last but not the least, print. If head is equal to null, we just put no elements in the linked list, or else it will iterate through all the elements until this temp is equal to null. Temp is a pointer, like an iterator, so it starts from head and until it becomes a we are iterating. So that's all.